Quick question. How many times have you heard the phrase problem solving in job ads, business meeting, or even everyday conversations and wonder what does problem solving really mean? We talk about it all the time, but do we really understand the process behind it? In today's video, I'm going to break down the engineering method of problem solving and show you how data science and statistical thinking play a crucial role in finding solutions to complex challenges. Hello everyone and welcome to the channel. So in today's video, I'm going to break down the engineering method of problem solving and explore the role of data science and statistical thinking. So if you're passionate about engineering, data science and problem solving, stick around until the end of the video. And don't forget to actually like and subscribe to the channel. So let's get started. The engineering method of problem solving. So what exactly is the engineering method? At its core, it's a structured approach engineers use to solve problems. And by problems, I don't just mean small technical issues. Engineers tackle large and complex challenges that affect society, whether that's refining an existing product or system or designing a brand new one. So the original method that I'm referring to is based on Douglas C. Montgomery's engineering method in his book Applied Statistics and Probability for Engineers. Here's a quick summary of his 8-step approach. 1. Develop a clear and concise description of the problem. 2. Identify important factors that affect this problem or that may play a role in its solution. 3. Propose a model for the problem using scientific or engineering knowledge. State any limitations or assumptions of the model. 4. Conduct appropriate experiments and collect data to test and validate the tentative model or conclusions. 5. Refine the model based on the observed data. 6. Manipulate the model to assist in developing a solution to the problem. 7. Conduct an experiment to confirm that the proposed solution is effective and efficient. And finally, 8. Draw conclusions and make recommendations based on the solution. Alright, so while this method is effective, it can seem quite detailed and overwhelming. So I'm going to introduce a simplified version, breaking it down into 4 core phases to make it clear to understand and apply. So here we have updated problem solving method, a simplified approach. Phase 1. Define and understand the problem. Step 1. Clearly define the problem. Step 2. Identify key factors. Phase 2. Model and test solutions. Step 3. Develop a model. Step 4. Experiment and gather data. Phase 3. Refine the model. Step 5. Refine the model. Step 6. Develop and test the solution. Phase 4. Implement the model. Step 7. Conclude and recommend. So several cycles or iterations of phase 2 and phase 3 may be required to reach the final solution. By the end of the video, you'll have a clear understanding of how these methods help solve complex problems and enable data-driven decisions. Phase 1. Define and understand the problem. Step 1. Clearly define the problem. So this is where it all starts. You need to have a full understanding of the problem before jumping to solutions. So a famous quote by Albert Einstein goes, "If I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solutions." So it's super important to define the problem properly. Now let's break this down a little further. When you define a problem, think about who is impacted by it, what exactly the problem is, where it occurs, when it happens, and why it's important to fix. So all of this gives us a solid foundation and ensures you are solving the right problem. Step 2. Identify key factors. Once you understand the problem, the next step is to think about what factors could play a role in solving it. These could be technical limitations, environmental conditions, or customer needs. Anything that influences the problem is important to consider at this stage. Defining the problem clearly. The first step. Okay, so before moving on to the next steps, let's dive deeper into why defining the problem clearly is critical. As I mentioned earlier, defining the problem is one of the most crucial steps in the engineering method. A well-crafted problem statement acts as a blueprint for the entire problem-solving process. Without it, you might end up solving the wrong problem or getting sidetracked. So, how do we define a problem clearly? What is a problem statement? So, a problem statement is a concise, clear explanation of an issue or challenge that summarizes what you aim to change. It helps you, your team, and other stakeholders stay focused on the problem, why it matters, and who it impacts. A good problem statement encourages awareness and sparks creative thinking without suggesting any solutions or leading toward a specific strategy. So, what should a problem statement include? A problem statement should outline the undesirable gap between the current state and the desired future state, helping teams dig into two critical aspects of problem solving. Where are we now? What's the problem? And where are we going? What's the desired outcome? So, it should provide measurable details to quantify this gap, but it should avoid identifying potential causes or solutions. Alright, so the key elements of an effective problem statement include gap. Clearly identify the gap or pain point that exists today. Time frame, location, and trend. Describe when and where the problem was first noticed and any trend associated with it. Impact. Quantify the gap in terms of cost, time, quality, environmental factors, personal impacts, etc. etc. Importance. Explain why solving this problem matters, whether to the organization, the individual, or another stakeholder, to emphasize the urgency of the issue. Alright guys, so the next question would be, how can I write an effective problem statement? One effective method to craft a strong problem statement is the 5W2H: what, when, where, why, who, how often approach. It's a straightforward but powerful tool. By asking the right questions, you can arrive at a clear, actionable problem statement. So, what is the problem? Identify the gap between where things are and where they should be. Clearly describe what's not working and what the ideal outcome would be. When does the problem occur? Is there a specific time frame or urgency linked to the issue? Understanding the timing helps with prioritization. Where does the problem occur? Does it happen in a particular location, department, or process? Narrowing down the problem's scope aids in targeting solutions. Why is solving the problem important? Why should resources and time be invested in addressing this issue? Recognizing the impact will keep motivation and focus aligned. Who is experiencing the problem? Identify the individuals, groups, or organizations affected. This helps clarify who is impacted and the extent of the problem. How is the problem observed? Look at the symptoms and manifestations of the issue. How often does the problem occur? Quantify the frequency, error rate, magnitude, or trend to better understand the scope and urgency. So, answering these questions results in a clear, actionable problem statement that keeps everyone on the same page. It ensures your solutions are addressing the root cause rather than just treating the symptoms. So remember, a problem statement isn't just a formality. It's a tool to keep the focus sharp and ensure that any solutions are relevant and effective. Phase 2. Model and test solutions. Now that we've clearly defined the problem and identified the factors affecting it, the next few steps focus on developing and refining solutions. Step 3. Develop a model. In this step, you begin to develop a model or hypothesis for how the problem can be solved. This is where you apply scientific, engineering, or business knowledge to make educated guesses about potential solutions. The key is to build a conceptual model that reflects your understanding of the problem and outlines how different elements interact. To make this more concrete, business process modeling techniques and tools can be highly effective. These tools provide a visual representation of processes, which is crucial for effectively monitoring, improving, and streamlining the flow of tasks. Tools such as flowcharts, BPMN, business process model and notation, UML diagrams can help break down complex workflows into understandable parts, offering insights into bottlenecks, inefficiencies, or redundant steps. So by using these visual models, you and your stakeholders gain a clearer understanding of the current state of operations and can identify key areas for improvement. This also ensures everyone is aligned on how the processes should look moving forward. However, remember that every model has its limitations and assumptions. It's important to state these upfront to avoid over-reliance on the model's accuracy and predictive capabilities. By recognizing the model's constraints, you can adjust your approach and validate it with real-world data before implementing any solution. Step 4. Experiment and gather data. Now that you've got a model in place, you need to test it. This involves gathering data to see whether your model holds up. The data you collect will either validate or challenge your assumptions. Phase 3. Refine the model and implement. Step 5. Refine the model. If your model isn't working as expected, don't worry. It's normal. This step is all about learning from the data and tweaking your model to better fit the reality of the situation. Step 6. Develop and test the solution. Now, once your model is solid, it's time to get practical and start developing solutions. By now, you've gathered enough information and tested various hypotheses to feel confident in your approach. At this stage, you also need to confirm the solution with experiments. Just because you've come up with a solution doesn't mean the process is complete. This step involves running a final experiment to ensure that your solution not only works, but is also efficient. Alright guys, now let's talk about the role of data science and statistical thinking. I'm really excited about this part. Now let's talk about the role of data science and statistical thinking in this entire process. Why is data science and statistical thinking so important? So, engineering problems often involve working with large amounts of data, whether it's related to materials, processes, customer needs, or performance metrics. Being able to collect, analyze, and interpret this data is crucial for making informed decisions. This is where data science and statistics comes into play. Statistics is essentially the science of data. It helps engineers make sense of the information they collect, ensuring that decisions are backed by solid evidence rather than assumptions. Okay, now let's break this down into 4 key components. First, data collection. Statistics guides you in determining how to gather the most relevant data. For instance, when designing an experiment to test your model, it's essential to decide what type of data to collect, how to collect it, and how much data is needed to make your results reliable. Second, data analysis. Once you've gathered the data, data science and statistics provide tools to analyze it effectively. Techniques such as hypothesis testing, regression analysis, and variance analysis allow you to detect patterns and trends. These insights help you evaluate if your proposed solution is truly addressing the core problem. Third, interpreting results. Data science and statistical thinking go beyond just crunching numbers. They help you understand what those numbers actually mean. For example, they allow you to distinguish whether observed improvements are meaningful or just random fluctuations. Fourth, decision making. Ultimately, data science and statistical thinking are about making better data-driven decisions. By analyzing the data and interpreting the results, you gain confidence that your conclusions are based on objective, factual evidence. For instance, when refining your model in step 5 of the engineering method, statistics help you adjust your assumptions using the data you've collected. This ensures that any changes you make are grounded in facts, not just intuitions. So, in summary, without data science or statistical thinking, the engineering method would be incomplete. You'd be relying on guesswork instead of informed data-backed decisions. This is why it's essential for engineers to be comfortable with statistical tools, whether it's for designing experiments, analyzing data, or interpreting results. To sum up, the engineering method gives us a structured step-by-step approach to solving problems. It's all about defining the problem clearly, gathering data, building models, and refining those models until we land on the best solution. And remember, data science and statistical thinking play a huge role in making sure our solutions are effective and efficient. Alright, so if you found this video helpful, don't forget to give it a thumbs up, subscribe, and leave your thoughts or questions in the comments below. Thanks for watching, and I see you in the next video.